Hello, it's Dave Giles here for the next lesson of Cambridge International Education IGCSE Physics, Unit P1, and today we're looking at resolving vectors graphically or using scale models. So, free learning objectives, I want you to use a scale to draw forces, determine the resultant of two parallel vectors, and use a scale drawn to determine the resultant of two perpendicular vectors. So, question here to start us off, use a scale of 1 centimeter with 5 newtons to draw the following. 20 Newton horizontal force to the right and a 10 Newton vertical force moving upwards. So for A, 20 Newtons, so that should be 1 centimeter is 5 Newtons, so that should be 4 centimeters. And 10 Newtons up should be 2 centimeters. Okay, so that's using a scale to draw very, very basic forces there. So when two or more forces are parallel, the resultant can be determined by adding or subtracting the vectors. For example, 50 newtons right, 30 newtons right, just add up 50, add 30, gives me 80 newtons right. Here I've got 60 newtons down, 20 newtons up. Now this time, these are acting in the opposite direction to each other. So instead of adding them, I will subtract. So 60 minus 20 is 40 newtons down. Okay, 2 seconds. So some very quick questions here on that. So pause it and I'll let you do it yourself. I will point out that obviously this here was designed for A4 paper, so it might be a little bit trickier to do the bottom one. Okay, 30 newtons to the right, 6 newtons to the right, 40 newtons down, and on here, on A4 paper rather, this line here is just have to double check. This line here and this line here, when you add them up, you get 50 newtons to the right. Okay, so moving on. We've looked at very, very basic vectors there where they are parallel with each other, and they're the easier vectors questions. The harder ones are when you've got perpendicular vectors. This lesson, we'll look at how to resolve them using a scale drawing, and later we'll look at, in a future lesson, we'll look at how to resolve them using mathematics, trigonometry, and Pythagoras. But for today, we're using scale drawings. So a boat is traveling at 12 meters per second east and 6 meters per second north. Determine the resultant velocity and direction of the boat. So you generally want a scale where it's going to take as much of the page as possible. Because if you make if you have it so it's taking up a tiny fraction of the page, and I say a lot of students do this, then what tends to happen is you get a lot more error in your final answer. So I'm using 1 centimeter is 1 meter per second. So I'll draw a vertical line here. Now, if you're using line paper, I would draw it on the line. So you know it's going to be perfectly horizontal. 12 meters per second. And then the upward direction is 9 meters per second north. However, when I draw the resultant here, it'll be pointing this way, which is obviously not, you can tell from this, it's going to be northeast. So what I should have done is actually drawn it on this side. So I'll move it across. Now, when I draw the resultant, which is here, I get 15 centimeters long. So 1 centimeter is 1 meter per second. So 15 meters per second is the resultant. And if I measure the angle, I get 37 degrees as my angle. Okay, so that's one I've worked through with you. Here's one for you to have a go at yourself. Pause it and try it. Okay, so there is, again, same scale, 1 centimeter is 1 meter per second. 8 meters per second east, 12 meters per second north, move it across. Resultant here, 14.4 centimeters, and so that is 14.4 meters per second at an angle of 56 degrees. Normally, there will be a little bit of a tolerance. So something like this, it would probably be something like plus or minus 0.1 meter per second. So if you've got somewhere between 14.3 and 14.5 inclusive, you'd probably get the mark. For this one here, maybe able to say 1 degree either way, so 55 to 57 degrees. Okay, so that's resolving perpendicular vectors. Now we're going to do it the other way around. So we're going to take a vector where we've got the result and then we're going to resolve it into its horizontal and vertical components. So I've got a little drawing up here of what's happening. I've got a skydiver being towed along and there's tension in the rope of 200 newtons, and between the boat and the rope, the angle is 30 degrees. So use a scale of 1 centimeter is 20 newtons. So it'll be like 10 centimeters long. The resultant, which should be take up quite a bit of an A4 page. If you've got room to make the scale so that it takes up more of the page, that's even better. But I'm using 1 centimeter is 20 newtons. So if you've got lined paper, I would do it from the line. So I would measure 30 degrees and then draw a 10 centimeter line, which will represent the 200 newtons. Pardon me. So the resultant here, sorry, not the resultant is given. So resolve it in its horizontal and parallel components. So this here is its horizontal. That's its horizontal and vertical components is its vertical. When you measure it, I get mine to be 8.7 centimeters, which roughly corresponds to 174 newtons. So in a question like this, probably have a range in your answer of somewhere between 170 and 180 approximately. And for this one here, I get 5 centimeters, which is 100 newtons. So again, you'd probably have a range of around 95 to 105 newtons as your vertical component. Okay, so that's one that I've worked through with you. Here's one for you to try yourself. Okay, pause it, and I'll go through it in a moment. Okay, so same scale as last time, 1 centimeter is 20 newtons. And I'm just going to add a little imaginary vertical line down the middle of my page here. And I will measure the 40 degrees from here. So it's 40 degrees and 280 newtons. So that would be 14 centimeters long. This line here, your vertical component, so your horizontal component should be about 9 centimeters, so 180 newtons. Something like this again, probably somewhere between 175 and 185 is acceptable. This line here is 10.7 centimeters, 214 newtons. So again, somewhere between 200 and 220 would probably be acceptable for this question here. So for that answer there. Okay, that's it for today's lesson. Thank you very much, everyone. I will be uploading the next lesson on maths needed for resolving vectors. So basically how to use Pythagoras and trigonometry if you haven't already done so in maths. I'll be uploading that soon. Thank you very much, everyone, and I'll see you later.